Hi friends, Namaskar and a very warm welcome to this channel and to this session. Well, I wanted to wish you all the very best for your upcoming exams, and I thought of making a small session talking not about the frequently asked topics but more important about the high-end topics or the high-end points for your exams. So in this session, very short 20-30 minute session, I will be discussing about the difficult topics. We will also talk about the frequently repeat difficult topics in your exams, the board-based questions, the confusing and the controversial topics. So of course, always to start with, let us talk a little bit about epidemiology, which is the study of choice for the burden of disease. Burden of disease, primarily you want to find the prevalence. We always do it by cross-sectional study. Natural course of disease is done using cohort studies. Rare disease, the study of choice for a rare disease. You want to study the disease which is rare. We do a case control study. Rare risk factors, we can do a cohort studies. For rare investigations, we have a special study that is called as nested case control. Please remember that the nested case control, it is a type of a cohort study. Nested case control is a type of cohort studies. For incidence, we do always a cohort studies. For prevalence, we do cross-sectional, multiple outcomes. You want to take a risk factor and then you want to find out what are the different types of outcomes which happen. So technically, we are going to do a cohort studies. Multiple risk factors, we are going to do a case control study. Short time taking is case control study. Long time takings are cohort studies. Hypothesis formulation will happen at a descriptive studies, whereas hypothesis testing would happen at analytical studies. Hypothesis confirmation would happen at experimental studies, evidence-based medicine, or even meta-analysis. To establish the final cause of disease, or to the best study or the final study to establish causation, that is meta-analysis. To find the attributable risk, what we can do is a cohort studies. A lot of times in your exam, they ask you about attributable risk. But attributable risk, it is the percentage of people. It is the percentage of people having the disease among the exposed group, which is due to their risk factors in the study. Let us say this is the world. And in this world, you want to do a study and you want to find out how many people have the risk factors. Let us say these are the people with the risk factors. So these are the people with the risk factors, and then you want to find out people with disease. You find out that these many people have the disease. If I just zoom into this area, if I just zoom into this area, I can say that there are people with the risk factors and there are people with the disease, right? So there are people with the risk factors and there are people with the disease. Now try understanding that the people who have the risk factors and who have the disease, these people. So there might be some people who got the disease because of the risk factors, and then there are some people who got the disease who did not even have the risk factors, right? So now out of this people, there might be some people who got the disease not because of the risk factors but because of some other variable. So the concept to understand this is what is attributable risk. Beta, what is attributable risk? It is the percentage of people having disease among the exposed group which is due to the risk factor in study. That funda is called as attributable risk. It is given by the formula incidence exposed minus incidence non-exposed divided by incidence exposed. On the other hand, talking about the population attributable risk. Population attributable risk is the same concept but in a general population. It is the percentage of people having disease among the general population which can be decreased due to a unit change in risk factor. Population attributable risk is given by the formula incidence in the total population minus incidence in the non-exposed divided by incidence in the total population And cohort studies will help us find out the attributable risk and the population attributable risk. But a correlation of the variables, that is done in a correlational study called as ecological study, and population-based studies are also the same answer, ecological studies. Moving over to the next point, that sometimes students get confused like what is a confounder and what is an effect modifier. So you already know that there is a risk factor which will cause a disease. Now there could be a third variable. Let me call that as a x variable. Let us just call it as the x variable. So now if the X variable could be a confounder or it could be effect modifier. How to find it out? So what you do is you stratify based on the confounder or the effect modifier variable. If there is some association in one group, it is called as effect modifier. That means there is some indirect effect. There is some indirect effect of the risk factor on the disease. But if there is no association in both the groups, that factor is called as a confounder. That means it was just showing a delusion or hallucination kind of phenomena. That factor is called as confounder factor, which in reality does not have any effect on the disease. It just confounds the result. So please note that on stratification, we can have effect modifier or confounder, and that's very one of the ways to say that stratification, it is a very easy and a very good method to find out or to eliminate any confounding problems. Next is sometimes students get confused about what is a yield of a test and what is the diagnostic accuracy of the test. The yield of the test is given by the formula that how many times the test has given us true positive plus the true negative result divided by the true positive plus true negative plus false positive plus false negative result. So technically we can say that the number of times the test speaks the truth divided by the total number of times the test would speak. That is called as the yield of a test. Next is what is a diagnostic accuracy of the test. Beta, the diagnostic accuracy is nothing but a positive predictive value. The positive predictive value is called as the diagnostic accuracy of the test. Sometimes students also get confused in what is a relative risk reduction, absolute risk reduction, and number needed to treat. Let us say that this is the number of people or the number of times the event has happened and number of times the event does not happen. And let us say that this is the experimental group and the other one is the control group. Okay, so let us call this as A, B, C, and D. Right? So what is relative risk? Relative risk is found out in cohort studies. We can find out the relative risk in cohort studies. It is given by the formula incidence in the exposed divided by incidence in the non-exposed. What is the incidence over here? Let us say that this experimental group is the people who are with the risk factor and the control group is people without the risk factor. So how much is the incidence in the exposed? Can I say that the incidence in the exposed, that is A over A plus B, because this people are the exposed group. On the other hand, what is the incidence in the non-exposed group? Incidence in the non-exposed group will be given by C over C plus D. This is the concept for relative risk. Now, what do we mean by a relative risk reduction? Relative risk reduction is nothing but the control group event rate minus experimental event rate divided by this total thing divided by the control event rate. Event rate. Sorry for my spelling, but that's how it is. Control event rate. So this is the formula for relative risk reduction, and very often they just ask you like what is the formula for absolute risk reduction and what is a relative risk reduction. What is absolute risk reduction? Absolute risk reduction is nothing but the control event rate minus the experimental event rate. What do we mean by, just I'm asking you like what is a control event rate? What is control event rate? See beta, the control event rate is that the number of times the event has happened in the control group, that is C divided by C plus D. It is nothing but incidence in the non-exposed population. It is nothing but incidence in the non-exposed population. And what is the experimental group event rate? Experimental group event rate. Experimental group event rate is given by A over A plus B. That is nothing but the incidence in exposed population. Incidence in exposed population. So absolute risk reduction is given by CER minus EER, and number needed to treat is nothing but 1 over absolute risk reduction. That is, you just inverse it, or 1 over CER minus the EER. What is CER and EER? CER, that is the control group event rate, and EER, that is the experimental group event rate. Next is, sometimes this has been asked very often to me on social media. The probability that a patient would test positive actually having a disease is called as. So you already know that there could be the people with disease or the event, and there are people without the disease, and the test could be positive or the test could be negative. So what should I write here? Test is positive and the people are diseased. That is the true positive. These are the true negative, the false positive, and the false negative. So bache, whenever the question is asking you that the probability that a patient is tested positive actually having the disease. So out of the total disease, how many are tested positive? That is true positive divided by the disease plus. This is what we call as sensitivity. On the other hand, on the same principle, what is specificity? That is true negative divided by the D minus. On the same principle, what do we mean by the positive predictive value? What is a positive predictive value? Positive predictive value is given by the true positive divided by tested positive. And the negative predictive value, that will be given by the true negative divided by the tested negative. So in very simple words, if I just want to say that this is the number of people having D plus, D minus, test plus, and test minus, you already know this is true positive, true negative, and on the other hand, we have false positive and false negative. So can you tell me what is this over this? This is positive predictive value. What is this over this? This is negative predictive value. What is true positive divided by the D plus? That is sensitivity. What is true negative divided by D minus? That is specificity. So please remember sensitivity and specificity. Sometimes the examiner may also ask you, like, what is sensitivity? What is the use of sensitivity? Please remember that sensitivity is used to rule out a disease, whereas specificity is used to rule in a disease. You can remember it by spin and snout. You can remember it by spin and snout. What is spin and snout? Specificity is used for ruling in the disease. Sensitivity, it is used to rule out the disease. Just remember spin and snout. To rule out, we use sensitivity. But the exam is just on your head. I know you might get confused sometimes. So make sure you get some mnemonics and don't bang your head on understanding like what's the logic behind this. For understanding the logic, it will again take us 4 to 5 years to understand everything. So my sincere recommendation is not fall into the trap of understanding the things right now, because you're just a few weeks away from the exam. Better is to get your head straight and to get your full focus and to make some mnemonics on the things which are right, so that you are able to recall them very clearly in your exam. Next is, sometimes people get confused like what is reliability, validity, and accuracy. See, if a person is giving the same results again and again, he's hitting the same area again and again, this result is called as a reliable result. This result is a reliable result. That is precision, reproducibility, and repeatability. What is validity? Validity means that you were able to get the results within a desired range. That is, you wanted to hit the target. Did you hit the target? That is called as reliability. That is what we call as reliability. Next is, what is accuracy? Beta, accuracy means nearness to the true or the absolute value. That is, nearness to the true or the absolute value. Did you hit a bullseye? Did you hit a bullseye? That is what we call as accuracy. Getting the results within a desired range is validity. Next is, sometimes examiner would ask you about receiver operator characteristic curve, ROC curve. Beta, ROC curve, it is drawn between sensitivity and 1 minus specificity. Please remember, say with me, it is drawn between sensitivity and 1 minus specificity. It is always drawn between sensitivity and 1 minus specificity. What is 1 minus specificity? That is nothing but the false positive rate or the false positive values. So ROC curve, which is a better curve, the better curve will always be the curve which is on the top and left. It is more towards the top and the left. That means it should have, why do I say top? Top means that it should be more towards the top side. That means there should be more sensitivity. Why do we say left? That means there should be less false positive, which indirectly means more specificity. So which is a good test? A good test is the test which is having high sensitivity and high specificity. That is, on a ROC, it should be more towards the top and the left. If a curve would lie, if a result of an investigation would lie at this junction, we would say that the test is not useful, because this is just a simple standard result and this result does not mean anything. So as you move towards this parabola, you can say that the test would be more significant and the test would be usable in the population. Coming to next topic, what is correlation coefficients? Beta, correlation coefficients, we can have a Pearson correlation or a Spearman correlation. Pearson correlation, it is used for linear correlations, whereas Spearman is used for non-linear or parabolic correlations We can also calculate something called as coefficient of determination, which is given by R square. What is R? R is nothing but, I have written it as an abbreviation for Pearson correlation. So if you just square up the Pearson correlation, that is called as coefficient of determination. As you can see in this image, we can see a largely positive correlation, because you can see that these values are just close to the line. So it tells you about what does correlation tell you? Correlation will tell you about the degree, it will tell you about the direction, and it will also tell you about the strength of correlation. It will tell you the degree or the strength and the direction of relation between two variables. It is always between two variables. It is always between two variables. So you can see over here in the image number 2 that the values are slightly more dispersed. So the more dispersed the values will be, the less or the lower the correlation would be, and the more condensed the values would be. That means it is a positive correlation, more significantly positive correlations. So using the correlations, we can also find out the regression. But over here, what you see over here in this image, you can see that the rho value or the R value, that is -1. So if the value of R is -1, or the rho value, if it is -1, it means a perfect negative correlation. So this one is that the rho value is more than -1 but less than 0. So it's like not perfect negative, but a negative correlation. This one shows that it is a positive correlation, and you can see that this is slightly positive or perfect positive. This one is slightly positive and R equal to 0. Using the correlations, we can also calculate the regressions. Regression is given by y is equal to a plus mx plus e, where e would stand for the error. M is the slope of the curve. X is the variable of interest. A is the intercept value, and y is the regression or the value which you want to find out. Regression is used for predictions. Regression model, it is used for predictions, and regressions and correlations, they almost mean the similar things. Correlation is more of graphical display to calculate the rho value, whereas regression is more to find out the confounders and to eliminate the confounders and to predict the values. It is prediction of one variable using another variable. Please remember that correlation, it's always with scatter plots. Next is, sometimes examiners trouble us again with superiority and non-inferiority and equivalence trial. I try to make a very simple diagram with this. Whenever we are going to test a drug, we want to test a drug that maybe the drug is something better, or maybe we want to test a drug that it is equal to the standard drug and has lesser side effects. And the effect of this new drug, which has lesser side effects, is not lesser than the standard drug. Try understanding that. Let us say there is a standard chemotherapeutic agent which has some anti-cancer properties, but it also has a lot of side effects. You invent a new drug which has anti-cancer properties but has lesser side effects. So what would you like to do? You would like to do an equivalence trial or a non-inferiority trial. Let us say there was an antibiotic, erythromycin, which we were giving for diphtheria, and you invent a new antibiotic that this antibiotic is much better than the previous one. So what trial would you do? You would do a superiority trial. So whenever we do trials, we take a minus delta value, that is the minimum lower value, and we have a maximum value. And this center value, this center point, that is the 0 point. So in superiority trials, beta, if the test which shows more than plus delta, this test will definitely show superiority. But the test which, or the trial which does not reach this line, this trial is not taken as a superiority. Like the drug in this trial does not show superiority, whereas the drug in this trial will show superiority. On the same principle, if you understand about non-inferiority, let us just call these trials, let me just name them as 1, 2, 3, 4, 5, and 6. It will be much easier for me to discuss with you. In a non-inferiority trial, let us say you want to test any chemotherapeutic agent, and you find out that in third number trial, in the trial number 3, you find out that it does not touch this, whereas in this one, it is touching the lower value. So that means that this test is towards, you would accept this trial, whereas this trial, it shows lesser than the acceptable range. So this trial, the drug that you were testing in trial number 4 is not useful. On the same principle, if you talk about equivalencies, sometimes you don't want mega results. You don't want the results to be more towards the positive side. You want to find out the equivalence, like you want to find out, let us say you're going to control maybe blood glucose. So if you're trying to control blood glucose, you don't want the blood glucose to be very low. You don't want the blood glucose to shoot up high. So you do a trial to say that I want my blood glucose to be within the equivalent range. So in those trials, like this would show equivalency, yes. And the other one, the 6th number trial, does not show equivalency because it shows superiority, right? The 6th number trial would show superiority. So in the diagram, which trials would show superiority? The 6 number and the 1 number shows superiority. The 3 number shows non-inferiority, and 4 number is definitely inferior trials. So that's how you just analyze these superiority, non-inferiority, and the equivalence trials. So next is a very frequently asked topic about the p-values. Examiners would love to ask you about the p-values. Beta, the p-value could be less than 0.05 or it could be more than 0.05. If it is less than 0.05, it is called as a significant p-value. That means the effect is observed and the null hypothesis is rejected. That means whatever was your alternate hypothesis, that is the one you are going to test, that is accepted. On the same principle, if the p-value comes out to be more than 0.05, that means it is a non-significant p-value, no effect is observed and the null hypothesis has to be accepted. That means there is no difference. This technically means there is no difference and the alternate hypothesis is rejected. Sometimes the examiner may also ask you, like, what about the null hypothesis? If I just say it as N0H, that is the null hypothesis. Please remember that the null hypothesis, if it was true in reality, and was rejected in the study, if it was rejected, this type of error, we call it as a type 1 error. On the same principle, if the null hypothesis was false in reality, and was accepted, in the study, that means you have committed a kind of error, and this type of error, we call it as a type 2 error. So please remember type 1 errors and type 2 errors. Type 1 is null hypothesis was true in reality and was rejected. If it was false and accepted, it is called as a type 2 error. You would also like to remember that between -1 and +1 SD, how many percent of the population? 68%. Between -2 and +2, we have 95, and between -3 and +3, we have 99% of the population lying. Next is, sometimes examiner may ask you, what is this graph? This is called as a choropleth graph. Please remember, this is not a spot map. Choropleth graph will tell you about the intensity. It tells us about the intensity of a variable on a map. Intensity of variable on a map. On a map, we find out the intensity of a variable. That is called as choropleth. It is not a spot map. Spot map will tell you about what? Spot maps will tell you about geographic location of a variable. They will tell us about the geographic location of a variable. What do you see here? What we see here is a box and whisker plot. Please remember that there is a lower whisker and there is upper whisker or the upper quartile. The difference between the lower and the upper quartile, that is called as the interquartile range. The center part of the box that we call as the median, we have a lower whisker and we have a upper whisker. If you understand this, a lot of times they will just show you what is this and analyze this. So what you see over here is beta that 50% of the population, each box will be 25. So what you see over here is that 50% of the population is lying like this and there is one outlier. So the outlier, it is towards the right side. Therefore, this is called as a right skew. It is called as a right skew or also called as a positive skew. It is called as a right or a positive skew. So what you see over here in this graph is the actual weight of students, actual weight of university students and male or female doctors. And you can see that the weight of the females was considerably less, which is understandable and it is biologically explainable. And the weight of male students, it was considerably higher, but both were right-sided skew. I hope you can understand that both were right-sided skew. That happens with the weight. Coming to the next topic, very frequently asked about the test of significance. We can have two types of test of significance, parametric or non-parametric. When do we say parametric? When there is a normal distribution, usual type of data is ratios and usual measure is mean. Examples of test of significance would be t-test, z-test, ANOVA or correlation coefficients. In case of nominal, ordinal or proportional data or any type of distribution, usually a not normal distribution, what test of significance we use? We use a non-parametric test. So I'm just showing you a simple, I have just made this look simple, but it is generally speaking, it's a very complex type of understanding where you want to decide which test of significance to be used. Generally speaking, beta, this whole thing is important from INICET point of view. We can have a normal distribution or a not normal distribution. Not normal is what we call as the non-parametric test. So for single group, non-parametric test, McNemer test. For independent two groups, we can use Fisher exact test or a chi-square. Generally speaking, you have to remember chi-square test. Numerical data which are ordinal, we use a Wilcoxon rank test. Wilcoxon rank test. In grouped data, we call it as a sign test. In ungrouped data or independent sample, we call it as sum test. So if the examiner is giving you three groups, which are ordinal data, what test of significance? You will use a sum test. But the examiner is giving you, for example, single sample, one group, and there were 3 times testing in this. So 3 times or 4 time testing. Then what is the test of significance you are using? We are using Wilcoxon rank sign test. More than 2 groups, we use a Kruskal-Wallis test, and usually we use a chi-square test if the values in a single group, they are more than 5. If the values are less than 5, we call it as a Fisher exact test. Then we also have McNemer test, that is for single groups. Coming to the parametric test, very simple to remember. Large sample we have is a Z test, small sample is T test. more than 3 groups we use as analysis of variance, and we have already done this, that to find out continuous or quantitative data variable, to find out the relationship or correlation, we use a Pearson correlation coefficient. Next is, sometimes examiner may ask you what is Cronbach alpha. Cronbach alpha will tell us about the internal consistency. Just remember this word. It tells us the internal consistency of a questionnaire. Usually whenever you're making a questionnaire or a survey, you would use Likert questions. What are Likert questions? They are agree, disagree. They are based on agree or disagree continuum. They are based on agree, disagree continuum, and that is what is the Likert scale. So Likert scale, any day, if it is more than 0.7, it is usually taken as acceptable, and more than 0.95, it usually means that the data or the question is directly duplicated. You need to delete it. So it may show redundancy rather than an ideal reality that the question was relatable and the question will tell you what you wanted to say. Like if you say that it's sunny outside, question number 1 is sunny outside, people will say agree, disagree, whatever. And the second question, for example, you would put as can you see the sun outside? So it doesn't mean anything. It won't give you extra data. You're just duplicating the information over here. So to understand the difference or to understand the reliability or the consistency of the questions, we call it as a Cronbach alpha score. Some of the new schemes in Government of India, beta, we have discussed this 1 lakh times in your exams, offline lectures and online lectures. Ujala, Ujjwala, Ujjavala, Indradhanush mission and Indradhanush scheme. Next is, please remember what is Amrit scheme, affordable medicines and reliable implants, comprehensive primary healthcare and PMJ. Under the comprehensive primary healthcare, community health officers were established in the health and wellness centers. What are health and wellness centers? These are upgraded sub-centers. So sub-centers have been upgraded as health and wellness centers when we include an official post of CHOs. What are CHOs? These are nursing officers. You should also remember what is a Poshan Abhiyan and what is a Poshan scheme. Poshan scheme under Ministry of Education. It is a new name for the midday meal scheme or the midday meal program. Poshan Abhiyan, that is to decrease low birth weight by 2% every year and anemia by 3% every year. Jai Vigyan is for rheumatic fever. Remember, Vayoshri is for elderly population. These are some of the important topics you should remember in your, at least in your INICET exam. Vaccines, immunization, cold chill, mosquito types, flight range, egg, larva, family planning methods, MEC. Beta, what is MEC? MEC stands for the medical eligibility for contraception, MEC. So medical eligibility for the contraception, there is a wheel, and this wheel is given by WHO. This is a WHO made eligibility criteria. So whenever it is 1 and 2, we can use it. 1 and 2, we can use the contraception. And in case it is 3 and 4, we generally avoid the contraception. 4 is contraindicated. So, for example, in this female or in this client, you can see that the patient comes with hypertension. The patient is coming with hypertension, and these are the general contraception which are available. So, you just move the lower part of the wheel and the numbers would correspond. Okay, so 1 and 2, that means you can use, and the patient or the client can choose any of the following. In certain situations, it's with some alphabets. 3, can you see over here 3G or 111? So what is this G? If you just look at the backside of this contraception MEC wheel, you can see that G stands for if the female is more than 6 weeks after after delivery and the female is non-breastfeeding. So in those situations, we are not using this contraception. So MEC, beta, MEC generally tells you the eligibility criteria to use contraception, for contraception. That is MEC wheel. Pearls index, you should be knowing it is per 100 women years. National health programs, please remember all the targets, strategy, indicators, health planning and healthcare system. I would just like to tell you about health planning and healthcare system. There are two types of management designs. We can have the qualitative design or the quantitative. Qualitative is organizational designs, personnel management and communication, information systems and management by objectives. Whereas on the other hand, quantitative designs, you can see cost benefit analysis, where we talk about money gains, cost effective about life saved, input output analysis, modeling analysis, system analysis, network analysis, CPM, that is the minimum time to complete the event. CPM is the critical path method. What is a critical path? Critical path is the path with the longest time, right? So in your exam, sometimes they also ask you about what are the instruments which are used in a chapter on environment. So instruments that are used, that can also be important for your exam. You should remember this. And many times they ask you about the occupational health. Occupational health. So in occupational health, which are the diseases with the chemicals exposure, that is sometimes asked. Please remember that single exposure point source. All cases happen within one incubation period. Multiple exposures with continuous source, more than one incubation period. And what you see over here, these are secondary waves. You also see secondary waves. In propagated epidemic, we have multiple sources, direct transmission or indirect transmission. Multiple peaks are there. The key feature is person-to-person transmission. Please remember, there is no person-to-person transmission. There is no person-to-person transmission in SEPs or in MEPs, in single exposure point source or multiple exposure point source. Next is, many times the examiner may ask you about blood or body fluid spills. In case of spills, we have to cover the area with disinfectant. Which is the disinfectant? We will use 1% hypochlorite solution. 1% hypochlorite solution, and it is to be left for how many minutes? To be left for 20 minutes. And where do we discard all these things? They discarded in the yellow container. Please remember the gloves to be discarded in the red container, the gloves to be discarded in the red container, and discard the gown, mask, shoe cover in the yellow bin. So everything goes to the yellow except the gloves to be going into the red color bin. Many times examiner may also ask you about the health indicators. Which of the following are health indicators? Please remember, there are delivery indicators, utilization indicators, and the other socioeconomic health indicators. Socioeconomic health indicators. So coming to the next topic about sustainable development goals. These are the sustainable development goals which you need to remember. Very important for your exam. MMR to be less than 70. Neonatal mortality less than 12. Under 5 mortality less than 25. Smart PSM data number 1, the formulas which have been very frequently asked to me in various social media platforms. Please remember, I have made a list of formulas for you to remember. So you can remember everything from biostats, sensitivity, specificity, from biostatistics, number needed to treat, attributable risk, population attributable risk, about the demography. Very important. This is a high yield topic. Demography, what is GFR, TFR, GRR, NRR, Pearl's index, dependency ratios, net protein utilization, corrected effective temperatures, and all. And so with that, thank you so much for joining in this session. And in case you like the content over here, please give us a thumbs up. Any feedbacks are always more than welcome. And I wish you all the very best. Please note that you have to strike hard and you have to strike gold. Go with full confidence. God bless you all.